me quickly go over some tips on using Microsoft Teams. It's a new normal, and it's possible that some of you may not be familiar with this application. Up the top of your Teams window, you're going to see a bunch of icons, and depending on the size of the window, it's going to be in the middle somewhere. You're going to see 3 dots. Clicking that will display all the other options that are available. And the main one you might need is the device settings. So that'll show you your audio, your speaker, your microphone, and camera options if you're having trouble with any of those. And towards the right up the top, you're going to see icons for your camera and mic. If you want to turn your camera off or you want to mute your mic, just click on those. They'll then appear with lines through them to indicate that they're off. However, you'll still be able to see and hear us. We also have an override switch here that's going to turn the mics off, but we can't turn them on again for you. So if you're invited to speak, please don't forget to unmute your mic first. And here on the left is an icon to show the participants. Click on that and you're going to see everyone that's present in the meeting listed at the right-hand side of the window. The next one along is the chat icon. If you click on that, it's going to open the chat box on the right of the window where you can see any comments that are going on and also add your own. And down the bottom there, where it says type new message, you can attach files, add emojis and GIFs and stickers and so on. Simply hit enter to submit after you've typed your comment, or click on the arrow at the bottom right. The third one along is where you can raise your hand if you want to ask a question or you want to contribute something. Clicking on that is going to show you the option plus a few others. The one on the far right is the one to select to raise your hand. That'll then display beside your name in the show participants display, where we'll hopefully see it and call your name to respond. Please don't forget to unmute your mic before you speak, and be aware that we're still getting used to all of this as well. So apologies in advance if we miss seeing your hands raised. In case that happens, please type your question in the chat box and one of the other team members should respond to you there. Okay, so this is the schedule for today's workshop. Session 1 and 2 is going to run for about 45 minutes each with a 5-minute break. That's going to be followed by a 15-minute general discussion. Okay, on to the meaty bits. Here's the list of topics that we aim to cover in today's session. I'll be going over some background information relating to Wi-Fi technology before discussing Wi-Fi standards and the various technology components, followed by a bit of antenna theory. Then we look at the menu options in Draetech routers, which we hope will help provide you a better understanding of what these features are and what they can be used for. We're going to have a short break after that, and then Dan's going to take over. He'll be looking at Wi-Fi mesh networks and some Wi-Fi deployment examples. Then we'll wrap it up with some handy troubleshooting tips. If you're interested, you can find the full content in our training manual. You'll find page references in the bottom right-hand corner on each slide. Okay, so Wi-Fi was first released to consumers in 1997 when a committee from the Institute of Electrical and Electronics Engineers, or the IEEE, created the 802.11 standards. The term Wi-Fi is actually a trademark phrase for the IEEE 802.11x standards created by the Wi-Fi Alliance, which is a trade association group formed back in 1999 to regulate the Wi-Fi market. Following this, a basic specification for Wi-Fi was established, allowing 2 megabytes per second of data transfer wirelessly between devices. This sparked a development in prototype equipment, such as routers and access points, to comply with the IEEE 802.11 And in 1999, Wi-Fi was introduced for home use. As we now know, Wi-Fi is a mature and reliable alternative for local area network deployment. The 802.11 series of protocols have defined all aspects of Wi-Fi operations, and the latest AC standard further defines more functionality, such as security, dual band, high throughput specifications. Further enhancements are the 802.11ax and AY standards, which promises even higher wireless data speeds. Now, here's a statistic that forecasts that the number of mobile devices is likely to grow to 16.8 billion in 2023, which is going to be double the world's population. Isn't that impressive? Let's get started with an introduction to Wi-Fi technology. So what is the role of Wi-Fi access points in a network? Well, the answer is that they provide a layer 2 bridge, allowing wireless devices or stations to join a wired network via wireless radio. One obvious advantage here is that there is no need for fixed data cabling. There's actually a list of advantages and disadvantages of Wi-Fi in our course notes on page 9 if you're interested. What all of this boils down to is that Wi-Fi has numerous applications. They range from things like accessing the internet to file sharing, wireless printing, streaming audio to any speakers in your house, or transferring photos from your digital camera, turning your smartphone into a remote control, and streaming movies to any TV in the house, just to name a few. One example of a commercial application for Wi-Fi is for the luxury hotel groups in the UAE, India, China, and other parts of the world to provide a service that's called DigiValet to their guests. In this application, Draetech bigger access points are deployed along with tablet PCs in each room. The solution allows guests to control lighting, air conditioning, TV and sound systems, as well as ordering their room service or browsing the internet, watching movies on demand, and much more. Let's quickly talk about Wi-Fi standards. As I mentioned earlier, Wi-Fi standards today are based on the 802.11 specifications that were created by the IEEE committee back in 1997. As the Wi-Fi technology developed through the years and network bandwidth gradually increased, letters were added to reflect the improvements. So now we have 802.11b, .11a, .11g, .11n, 11ac, and up to AX. The Wi-Fi naming convention has been changed recently, so it starts with Wi-Fi 1 for the earliest Wi-Fi standards to Wi-Fi 6 for the latest. So the highest number indicates the latest standard. Now here's a table that shows the different 802.11 Wi-Fi standards along with the frequency of bands that's being used. Both the 2.4 and 5 gigahertz frequencies are unlicensed bands which can be used freely. Most of the other frequency bands in the RF spectrum require a license and are mainly for commercial uses. When setting up your Wi-Fi network, we often have to decide whether to use the 2.4 or the 5 gigahertz band. We have some points to consider, of course. The first is interference. The 2.4 gigahertz band is very crowded and it's used by many devices. So in multi-tenant buildings, it can be difficult to find a free channel. On the other hand, the 5 gigahertz band offers more channels and it's usually less congested, which will result in less interference. Another point to consider is the traveling distance, where the 2.4 gigahertz is better suited for larger areas where the signal can travel further. The 5 gigahertz, on the other hand, has shorter range, usually about 30 meters or so. So it's better suited for office networks or where higher speeds are required. .802.11ax is the latest addition to the Wi-Fi standards, and it comes with several advantages, including improved data rates and better efficiency. Dratec is in the process of releasing new products using the 802.11ax technology. The first one we released is the Vigor AP 960C, with more to follow in the coming months. And here's a table with comparison between the 802.11ac and .11ax technologies. Part of the 802.11ax efficiency comes about thanks to a technology called Ofdma, that's orthogonal frequency division multiple access. Comparing it to the current OFDM technology, where each frame is transmitted across the entire channel width, OFDMA basically splits each Wi-Fi channel into tiny chunks, allowing multiple devices to transmit and receive simultaneously on the same channel. So basically, more devices will get more bandwidth simultaneously for an overall faster Wi-Fi network. All right, so time to check if you guys have been paying attention. Here's a quick quiz question for you. What is the Wi-Fi 5 also known as? Is it A, 802.11a? Is it B, the 2.4 gigahertz? Is it C, 802.11ac? Or is it D, 802.11ax? I request you to raise your hand if you'd like to answer this one. Or if it's easier, just type your answer in the chat box. Oh, there you go. Everyone's going on. That's good. All right, looks like we've been doing a decent job here, telling you exactly what the right answer is. You're right, it is 802.11ac. Good job, everyone. 2 thumbs up. On your screen here is the table again with that list of Wi-Fi standards, which are now named Wi-Fi 1 up to Wi-Fi 6, along with their applicable networks and frequency bands. Just remember, the larger the number, the later the standard. Good job. Okay, how about another one? This time it's going to be multiple choice questions, so pay attention. What are the 2 most common unrestricted frequency bands that are used for Wi-Fi? Use the chat box if you'd like, or raise your hand if you'd like to answer this one. Go for it. All right. Excellent. There you go. Josh and Tristan, Brad. Good job, Anton, Troy, everyone. That's good. Excellent. So the answer is A and C. That is the 2.4 and the 5 gigahertz. Just remember that the Wi-Fi 6 will eventually be extended to Wi-Fi 6E, which will include the 6 gigahertz frequency. As to when we're going to see the 6 gigahertz band open up in Australia, it's not likely until at least sometime in 2022 from what we hear on the grapevine. Bear in mind that the client devices will need to support it. And since it has shorter wavelength than even 5 gigahertz, it's not likely to have a huge range. So it's going to be best suited to indoors. That's all we know about this standard at this stage. And a quick note that Draetech have not yet announced if or when they're going to be introducing any 6 gigahertz products. All right. So moving on to wireless technology components. First, we're going to talk about channel separation. Since each frequency band uses a 20 megahertz channel width and occupies 22 megahertz in the RF spectrum. There is an overlap of each channel in the 2.4 gigahertz band, as you can see here. So channel separation occurs every 5 channels. So to avoid interference between adjacent access points, it is recommended to configure the Wi-Fi channels to be 5 channels apart. So just as an example, it's recommended that you use channels 1, 6, and 11 for adjacent access points. There's actually an option in Draetech devices to extend the channel width to 40 megahertz by using extension channels. Although this is going to improve your data rate, it will increase the chances of interference of neighboring APs if they use the same channel. Now, here's a screen a lot of you are very familiar with. The config menu of a Vigor 2865. You can see the option to increase the channel bandwidth here. By default, the 2.4 gigahertz frequency band uses a 20 megahertz channel width. A 40 megahertz channel width is going to bond two 20 megahertz channels together, which is going to allow for greater speed and faster transfer rates. Now in the 5 gigahertz Wi-Fi band, we can have a channel bandwidth of 80 megahertz. This basically bonds 4 20 megahertz channels to give us the 80 megahertz bandwidth, which effectively gives us two 80 megahertz channels, that is 36 to 48 and 149 to 161. Please note that channel 165 only supports 20 megahertz channel width, and using the 80 megahertz, the expected data transfer rate is over 400 or 500 Mbps in Dratec routers. Now, here's a term that you're going to see often when we talk about Wi-Fi. It's MU-MIMO, which refers to multi-user, multiple input, multiple output. This was actually created to improve the capacity of wireless connections. This technology is available in both the AC and AX Wi-Fi standards. It's useful for environments where multiple users are trying to access a wireless network at the same time. It allows multiple frames to be transmitted to different receivers at the same time and on the same channel using multiple streams to provide greater efficiency. Wave 2 MU-MIMO was introduced in 802.11 AC Wi-Fi, which is available in the current range of Draetech AC wireless routers and APs. Another technique that's used is beamforming, where the phase and the relative amplitude of the signal at each transmitter is sent at slightly different times so that in a particular direction, the signal strength is amplified towards the Wi-Fi client. To understand this, I'll talk of an analogy. When you throw two rocks in a pond, you'll see water waves emanate in all directions from where the rocks entered. Now, where the waves come together, there is a stronger or a bigger wave, that is a beam. And throwing the rocks into the pond at different times effectively changes the direction of the strongest wave. Another buzzword is Airtime Fairness, which is a technology which can be used in a sort of a mixed environment where slow Wi-Fi devices can significantly impact the performance of faster Wi-Fi devices. When using packet fairness, slow Wi-Fi clients take longer to transmit the same amount of data as faster clients, which basically slows down the whole network, since only one device at a time can transmit and receive data. In the diagram, we have the slow client shown as tortoise, which slows down the entire network. And by using airtime fairness, all your Wi-Fi clients are given an equal time slice. So slow clients like the tortoise cannot hold up the data queue. It's important to note in dual band devices that the airtime fairness settings in the 2.4 gigahertz Wi-Fi is independent of the 5 gigahertz band. Now, band steering is a feature which encourages dual band capable devices and wireless clients to connect to the faster 5 gigahertz Wi-Fi and leave the 2.4 gigahertz channel less crowded, thereby improving overall Wi-Fi performance. In this diagram, we show that without band steering, the 5 gigahertz capable devices could still be using up the 2.4 gigahertz channel and cause unnecessary congestion on this channel. There we go. With band steering enabled, the 5 gigahertz capable devices have moved to the 5 gigahertz band, freeing up bandwidth in the 2.4 gigahertz channel. Okay, time for a nice little video that's going to explain airtime fairness and band steering in more detail. This one runs for about 3.5 minutes. All right, anytime now.
Hi everyone, Darren from DrayTek Australia and New Zealand. Two very cool wireless features available on DrayTek Wi-Fi routers and APs are airtime fairness and band steering. You may have wondered what exactly they do and how they can improve the performance of your Wi-Fi network. Airtime fairness allocates bandwidth to wireless clients according to time rather than speed, so faster wireless clients aren't penalised by the slower ones. Let's assume, for example, that we have a network with a slow wireless device and a fast one. Each device gets an equal share of the bandwidth. Let's say, just using example values here, the actual values are quite different. The slow wireless client takes 1 second to download 1 packet of data. If the fast client is also only allowed to download 1 packet as well during its turn, it can download the same packet in a quarter of the time, but its overall speed will be impacted because it continually has to wait on the slower device. But if we change it to a time-based share of the bandwidth and each device gets the same amount of time to download as much as it can, the faster device can now download 4 packets during its turn instead of just 1. You'll find this setting in the web user interfaces down in the wireless LAN sections. For dual band routers and APs, it needs to be enabled for both 2.4 GHz and 5 GHz. For tri-band, it appears under all 3 wireless LAN settings. It's simply a matter of ticking the box to turn it on. The triggering client number is the number of devices you want online before it comes into play. The default is 2, which means it starts doing its thing anytime there is 2 or more Wi-Fi devices connected. Band steering also helps speed up a wireless network by reducing congestion on Wi-Fi bands. Let's assume we have a mixed network with some single band and some dual band capable devices. Band steering will automatically steer the 5 GHz capable devices to the 5 GHz band, freeing up the 2.4 GHz band for those devices that can only do 2.4 GHz. You'll only find this setting on dual and tri-band routers and APs in the 2.4 GHz wireless LAN settings section. For it to work, the SSIDs and security settings need to match on both the 2.4 GHz and 5 GHz settings. There's a tick box to enable or disable it, and check time for WLAN client 5G capability is set by default to 15 seconds. That's the time it will prevent a detected dual band capable device from connecting to the 2.4 GHz band, which should be enough time to get it to connect to the 5 GHz band instead. In more advanced products, we get a few more options to play with if we want to fine-tune it a little. 5 GHz minimum RSSI. RSSI stands for Received Signal Strength Indicator, so that's how weak or strong we want the signal strength of a particular device to be before it gets steered to the 5 GHz band. Then we have overload thresholds, which is how congested we want a particular band to get before it starts steering devices. It explains all that in a bit more detail there by saying band steering will only happen when 2.4 GHz is overloaded and 5 GHz is not.
Excellent. Thanks for that, Darren. Well done. I hope all of you found that useful and informative. And let me just remind you, there's a chat box right there on the screen. If you have any questions at all that need answered, please feel free to ask. Team's on hand to answer your questions and queries. Could be anything, bouquets or brickbats, just keep them coming. Now, moving on to wireless roaming. This is when a client is moving around in an area with multiple APs. It can automatically switch to another access point with better signal strength. In traditional roaming, the wireless signal handover is the decision that's made by the wireless clients. And we often find that wireless clients tend to stick to the original connected AP, which has a weak wireless signal, rather than roam to an AP with a stronger signal. DrayTek APs provide AP-assisted client roaming, which basically assists wireless clients to roam more effectively. Network admins can set up conditions related to RSSI or link rate to kick out the wireless clients with poor signal to help them transfer to another AP with a stronger signal. Okay, let's briefly look at some antenna theory related to Dratec routers and access points. You can find more details in Chapter 5 of our training manual. Now here's the first antenna type we'll be talking about. This would be the omnidirectional antenna. These antennas radiate or receive wireless signals in all directions, so they have 360-degree coverage. They're suitable for covering confined spaces, such as the inside of a building. Pictured here are some examples of omnidirectional antennas, both dual band and single band, that are used with Dratec wireless routers and APs. Omnidirectional antennas have a donut-shaped radiation pattern that covers 360 degrees, which makes them ideal for connecting devices that are on the same plane and to either side of each other. This diagram shows that for a vertical omnidirectional antenna, the radiation is spread out in a horizontal pattern, which make them well suited for devices located on the same floor in a building. The floors located above and below will obviously see reduced signal strength. A directional antenna or beam antenna radiates or receives greater power in a specific direction that allows increased performance and reduced interference from unwanted sources. The signal is concentrated in one direction with almost no signal behind it in the opposite direction. They are suitable for covering specific areas in a building such as a classroom, or for point-to-point wireless installations such as a building-to-building wireless link. An example of a directional antenna that's used with Dratec wireless routers and APs is the ANT2520 shown here. Okay, get set. It's time for another quick quiz question. What are the two main types of antennas used for Wi-Fi? We just spoke about this. If you'd like to answer this one, please raise your hands or just type it in the chat box. Do we have any hands raised? Ah, there we go. Okay. Brad, Anton, good job. Martin, excellent. Thank you. Ming as well. All right, that's good. Looks like everyone's paying attention. The answer is omnidirectional and directional antennas. That's good. I want to round things up a bit. How about another question? This one's going to be a bit of a curveball. So where would you typically use a directional antenna? Please raise your hands if you'd like to answer this one. F, Martin, there's no F. But that's fine. I think by F you mean none of the above or all of the above. Either way. Thanks, everyone. Yeah, that's right. You meant D. It's good, but tell you what, the actual answer is it could be applicable almost anywhere. Because directional antennas, do remember, they are suitable for focusing the majority of the wireless signal in a particular direction. For example, to cover a specific area in a building, such as a classroom, or for point-to-point wireless links, such as buildings, or a building-to-building wireless link. Different antennas have different beam patterns, so you can target the area you want the signal to cover while reducing it in unneeded areas. For majority of standard installations where you want a general sort of a coverage in all your directions, an omnidirectional antenna is more suitable. Okay, so let's take a look now at the Draetech routers wireless menu. Shown here are the Wi-Fi options for both the 2.4 and 5 GHz bands, as they appear in the main menu of a dual band bigger 29 to 27 AC model. Single band models will, of course, only have the 2.4 GHz band, and some like the tri-band bigger AP 1000Cs will have 3 bands to configure, which are one 2.4 GHz and 2 separate 5 GHz bands. The menu options available for each Wi-Fi band are very similar between different models. Let's have a brief look at them, shall we? I'm going to start off with the general setup. We get similar options for both bands, with just the mode and channel selections being different. 4 SSIDs can be configured. Options for each SSID include hide SSID, isolate member, and isolate VPN. Now here's a table that shows you the available channels for both Wi-Fi bands. If left on auto select, the router or AP will choose the optimum channel for you. Be aware of DFS, also known as dynamic frequency selection in the 5 GHz range. The bands from channel 52 to 140 are also allocated to military radar, satellite communication, and weather radar. In some Dratec models, these channels won't be available at all, but in the models that do support DFS, selecting one of these channels or the auto select option will cause a warning to pop up. A requirement for Wi-Fi products to use these bands is they first have to scan and detect that it's not already in use by one of these services, and then rescan every 24 hours. Of course, during the scanning process, the Wi-Fi service will not be available. Moving on to the security settings. This menu option allows the configuration of security settings for each SSID. Now, there's 4 of them. And you can select the security mode and WPA settings. For added security, each wireless router is now supplied with a PSK, or a pre-configured password, if you will. This unique Wi-Fi password for each router is printed on a label that's at the base of the router. When selecting a security protocol, it is recommended to select a later version such as WPA2 or WPA3. WPA3 is available in the latest Draetech wireless routers and access points. Here we have a comparison of the 2 types of authentication. The main difference is that PSK uses a shared passphrase, whereas 802.1x is more secure and requires a username and password for each client. Moving on to access control. As the name suggests, access control is used to restrict access for certain wireless clients based on their MAC address, which can be entered into a black or a white list. The black list will, of course, block Wi-Fi clients with a matching MAC address, while those in the white list will be permitted to connect. This can be configured for each SSID. Next option on the menu is WPS. WPS, or Wi-Fi Protected Setup, provides an easy method to make network connections between wireless stations and an access point using WPA and WPA2 encryption. With this method, there is no need to select any encryption mode and enter a long encryption passphrase to set up a Wi-Fi connection every single time. Instead, all you got to do is press a button and WPS will establish the connection between the wireless client and router automatically. To turn on WPS, method 1, just press and hold the wireless LAN on/off/WPS button that's at the front panel. Or if the router isn't easy to get at, you can log into it and go to wireless LAN WPS and click on Start PBC. The ACT and WLAN LEDs will flash rapidly for about 2 minutes, waiting for connections. During those 2 minutes on the wireless client, simply select the router's SSID and click on Connect, and that's it, job done. Moving on to WDS. WDS, or the Wireless Distribution System, is a protocol that's used to wirelessly connect APs or wireless routers. It can be used to wirelessly bridge two LANs or extend the coverage of a wireless LAN. There are two modes available, which are bridge mode and repeater mode. Okay, moving on to advanced settings. Here's a look at the advanced settings menu, where we can change parameters such as the operation mode, the channel bandwidth, etc. Next item on the list is station control. Station control is used to specify the duration of the connection time and reconnection time for wireless clients. This feature is useful when a business such as a cafe that provides free Wi-Fi to their customers. It prevents Wi-Fi users from hogging the network. In the example that you can see on your screen, we have limited the Wi-Fi connection time to be 1 hour for each user. And each user is also limited to 1 session each day. So they'll have to come back the next day if they wish to continue using the free Wi-Fi. Let's quickly talk about bandwidth management. True to its name, bandwidth management allows a limit to be set for Wi-Fi traffic to prevent some applications such as FTP, HTTP, or some P2P from consuming all the available bandwidth. Next up is AP discovery. This function is used by a bigger router or access point to scan the available Wi-Fi channels and produce a list of nearby access points. This information can then be used to select a suitable Wi-Fi channel to give the best connection. Clicking on Statistics will display the number of APs per channel, along with recommended Wi-Fi channel to use. Now, here's a handy little Android app that can also help work out optimum Wi-Fi channels. It's called the Wi-Fi Analyzer. This will show all of the wireless devices within range in the area along with their signal strengths in a neat graphical format. It does so for both the 2.4 and the 5 gigahertz bands. Pictured here, we see there are a few neighbors using channel 1 as yellow, and there's another one on channel 10. So I've put one of my APs in green there on channel 6 and the other in red on channel 13. This app has ads, but it's free to download from Google Play. Before we move on to Airtime Fairness, just want to remind everyone, in case there are any questions, queries, please feel free to type. Staff is on hand and they're answering questions as I continue my presentation. About Airtime Fairness, we've discussed this previously. It's best used in mixed environments where slow Wi-Fi devices can significantly impact the performance of faster Wi-Fi devices. This airtime fairness is triggered when the configured triggering client number is reached. We've set it up as 2 here. That's the default. Okay, talking about band steering. This is only found in the 2.4 gigahertz Wi-Fi menu on dual and tri-band models. Like we discussed, band steering encourages dual band capable wireless clients to connect to the faster 5 gigahertz Wi-Fi and leave the 2.4 gigahertz less crowded for those clients who support the 2.4 gigahertz only, thereby improving the performance for all of your Wi-Fi clients. For this to work, do remember that you need to have identical SSIDs on both the 2.4 and 5 gigahertz wireless LANs. Next up is roaming. Roaming allows wireless clients to reconnect to another access point with higher signal strength when moving within an area that's serviced by multiple APs. Each access point must have roaming enabled. And as you can see here, the menu option looks different in the Vigor AP 903. Finally, the last item on the menu is station list. Now, station list displays the information of connected devices. This information includes IP address, MAC address, and associated with. The status will show us whether it's connected or not and what sort of encryption is being used currently. Under the Advanced tab, we get more details such as AID, RSSI, rate, BW, PSM, WMM, PHMD, and MCS. Clicking on the Neighbor tab, we can see vendor information, approx distance, SSID, and visit time. Now here we have the station list for access points. The Vigor AP 903 is shown here. This includes a graphical display showing the number of Wi-Fi clients over a 24-hour period. Now just a quick look at the other menu options that are available in access points. One of the differences you may notice in Draetech Vigor access points compared to our routers is that they have an array of operation modes that can be selected. Later model access points have different selections and includes the Wi-Fi mesh options. Okay, so before we have a brief intermission and hand over to Darren, we do have some time for any questions you may have about the session so far. Okay, I see there's a bit of conversation going on in the chat. Please feel free to jump in and ask questions. We welcome your queries and we're here to help. It's going to be a 5-minute break now. And during this break, we're going to be on hand to answer any of your questions. So time for a quick breather, a quick coffee, if you will. Be back in 5 minutes, and Darren's going to take over for the remaining session. Thank you for your attention. Really appreciate your time.
Okay, a new wireless access point. The Vigor AP960C should be the first 802.11ax Wi-Fi product from Draetech to hit our shores, which should hopefully be early 2021. What's 802.11ax, you might ask? Well, without trying to explain it in too much detail, yes, it is a bit faster, but it's not that much faster than 802.11ac. Certainly not the same increase that we got from 11G to 11N or 11N to 11AC. Its main advantage is that it takes MU-MIMO technology a step further by applying it to both upload and download links, along with some brand new technology called Ofdma to allow more Wi-Fi devices to transfer data simultaneously for greater bandwidth overall. For more detail about 802.11ax, give it a quick Google. It's also known as Wi-Fi 6, and there's a version in the pipeline called Wi-Fi 6E, which is going to offer Wi-Fi in the 6 GHz spectrum. Up until now, we've only had Wi-Fi in the 2.4 and 5 GHz spectrums. We should also see 802.11ax versions of most of the router series as well, sometime in 2021, but those are still in the development stage at the moment, so we're not sure when they might go into production. It's ceiling mountable with a nice sleek design to be no more obtrusive than a smoke alarm. It has wireless mesh capability, so you can link a bunch of them together for coverage over a large area. Now, you will need wireless client devices that also support 802.11ax to take full advantage of it, but in the meantime, 802.11ax is also backwards compatible with existing 802.11ac and 802.11n Wi-Fi. Part of the 802.11ax advantage I mentioned comes about thanks to a technology called Ofdma. That's orthogonal frequency division multiple access. Comparing it to the current OFDM technology, where each frame is transmitted across the entire channel width, Ofdma basically splits each Wi-Fi channel into tiny chunks, allowing multiple devices to transmit and receive simultaneously on the same channel. So basically, more devices will get more bandwidth simultaneously for a faster Wi-Fi network overall. There's a new Wi-Fi encryption method called WPA3 available as well, along with features like Airtime Fairness and band steering that we've come to expect in DrayTek APs and Wi-Fi routers. It supports AP mode, range extender, and mesh nodes. And it can be managed as part of a mesh or from a Vigor router console, or using the free Vigor Connect application, or with Vigor ACS2 central management application. Here's a handy comparison table of Draetech APs. Here's a second page showing other features. And we have central management from a Vigor router console, or with Vigor Connect or Vigor ACS2. And speaking of ACS2, there's a new version called Vigor ACS3 coming soon. ACS stands for Auto Configuration Server and is Draetech's remote management tool for Draetech devices. It's a great tool for IT professionals to monitor and maintain multiple networks remotely. From what we've seen of ACS3 so far, it remains largely the same, with all of the monitoring and drag and drop VPN creation features and so on that we have with ACS2, with just some additions like the SD-WAN feature I mentioned earlier for the Vigor 2927 series. Well, so far anyway. We expect other models will be added in due course. Here's some highlights of some of the improvements. So there's a bit more than just the addition of SD-WAN. The dashboard view is much improved compared to ACS2. Here's a closer view of the dashboard. Here's the SD-WAN view showing some active WAN and VoIP connections. So the SD-WAN view basically shows us components and topology, and we can do some application optimization and monitoring. In the device view, we can get detailed information about devices and statistics for each device that we're monitoring. For more information about Draetech products, please check out our website at www.draytech.com.au or send us an email to sales@draytech.com.au or give us a call on 02 9838 8899. Thanks and bye for now.
Right, thanks for that, guys. Looks like it's time for the second session. Hope you're ready. I'm gonna pass you on to the able hands of Darren. Take it away, mate.
No worries, I'll just share my screen. Okay, hi everyone. I'll be taking over for the remainder of the workshop today. Joe finished off previously with a mention of mesh. Let's now look at configuring Wi-Fi mesh networks. This is covered in detail in Chapter 8 of our workbook if you want to follow along. So Wi-Fi meshing allows you to create a fast and reliable Wi-Fi network covering a large area. They don't need cables, so they're ideal for homes, offices and large areas that are difficult to extend wireless coverage by using structured network cabling to each access point. Draetech's mesh solution supports a maximum of 8 VIGA access points in a mesh group, which includes 1 mesh route and up to 7 mesh nodes. The mesh nodes can be up to 3 hops away from the mesh route. An easy way to set up a mesh is to use the Quick Start wizard found in the web interface in the VIGA access point or routers. Using the wizard will guide you through the process. So start by selecting the operation mode and set up the Wi-Fi details and password. After clicking finish, just power on the other APs that you want to add to this mesh group, and the wizard will then search for them and create a list. Then just go through the list and select the access points you want to add. Note that the access points must be in their factory default settings to allow auto discovery and configuration. These will then appear as mesh nodes, while the AP that we're working with here will be the mesh route. Another way is using a wireless app, which Dratec have developed for both Android and Apple iOS devices. These apps can be downloaded from the App Store for for Apple devices or Google Play for Android. It can also be done manually as well using the web user interface. Let's check out a video showing all 3 of these methods. This video is available on YouTube at the link shown down the bottom there if you'd like to check it out again. I'll see if I can copy and paste it to the chat box as well. No, it won't let me copy. All right, so over to you, Edward, to play the video.
Hello everyone, my name is Ashutosh Sabharwal. In this video, I'm going to show you how to set up a wireless mesh network using two Draetech Vigor AP903. Before this, let's first try to understand what is Wi-Fi mesh technology. Wi-Fi mesh technology is a plug-and-play technology used to easily configure a Wi-Fi mesh network. It simplifies wireless bridging of wireless access points to provide extended coverage in a network. The mesh route is first configured, then up to 7 mesh nodes can be added to form a Wi-Fi mesh network as shown in the diagram. Meshing provides the optimal path to an access point, adding redundancy and reliability. The self-healing feature of the mesh technology ensures an alternative path will be built in the event of uplink failure, ensuring continuity of Wi-Fi services. Currently, Wi-Fi mesh technology is supported only in these devices, but more devices will be added in future. Let's first start by looking at how to configure a mesh root device. Before configuring a root or a node device in a mesh network, make sure all the devices are restored to factory default settings. There are three ways to configure a mesh network. One is through Quick Start Wizard. Another is to manually configure through Dratec user interface. And the third is through DrayTek wireless app. Let's configure it through Quick Start Wizard. Connect your AP903 with a laptop or a desktop, and then open the browser and log in to the access point using its default IP, that is 192.168.1.2, and admin as username and password. Click on Quick Start Wizard and select the operation mode as Mesh Root. Give a name to the group and click Next Step. Enter the Wi-Fi SSID name and password. If you wish to enable second Wi-Fi, you can do this by enabling this checkbox. This Wi-Fi setting will apply to all the node devices in the network. If you like to change the default admin username and password, this can be done from here. But keep in mind that this will also apply to all the nodes in the network. Before you hit finish, go through the configuration settings. After hitting finish, the access point will provision itself and will start to look for nearby access points to add them as a node in a mesh network. Select all the access points which you like to be a part of mesh network. Give them a name and hit apply. This shows root device has successfully provisioned the node device. To check for the recently added mesh node device, click on Mesh and then on Mesh Status. The device with hop count 1 is the recently added device. The green indication means the device is ready. The yellow indication means the device is being provisioned. And red indication means the root device is not able to communicate with the node device. Let's now look at how to manually set up a mesh network through Draetech web user interface. Log in to the access point and go to operation mode. Select mesh root and click OK. It might take few seconds to set up a device as mesh root device. To see if a device is set up as a root device, we need to select mesh status under mesh. Check for the link status, which should show connected. To configure a node device, go to mesh setup and click on search under add mesh node. This search will list down all the available access points. Select all the access points which you would like to be a part of mesh network. Give them a name and hit apply. It might take few minutes to provision the node device. This shows the node device has been added. To verify the node device is synced with root device, go to mesh status. If you have multiple access points configured, you can isolate them with the device name or the MAC ID. If you wish to change the Wi-Fi SSID username and password, you have to make the changes in the root device. Once done, you have to go to Configuration Sync under Mesh and check all the options for which you like to distribute. Like in this case, we changed the SSID for wireless LAN 2.4 and 5 GHz band. When you hit apply, the modified parameters would be synced to all the nodes in the network. The new Wi-Fi SSID should reflect on all the node devices. Let's discuss the last option to configure the wireless mesh using DrayTek Wireless app, and it can be downloaded from Android and iPhone App Store. The first step is to connect to the Wi-Fi of the root device, and for that we need to click on Quick Start Wizard and enter the SSID and password to join the network. Once you are connected, select the operation mode as mesh root, give a name to a group and hit next. If you like to change the Wi-Fi SSID, this can be done from this option. Important thing to remember here is that the same SSID would be synced with all the devices in the mesh network. You also have an option to enable the second Wi-Fi, which can be done from here. This option allows you to change the login credentials. Remember, these credentials will be synced with all the devices in the network. Check for all the settings and hit finish. Join the new Wi-Fi network as we changed the Wi-Fi SSID. Once you are joined, the application will search for all the node devices in the network, so make sure all the access points are powered on. It might take a minute to search all the APs and will populate all the searched devices. Select all the APs which you would like to be part of mesh network. Give them a name and hit next. Once you hit apply, all the parameters will be synced with all the selected node devices. This shows the added node device and you need to hit finish to end the setup. If you wish to check for the added device, click on Devices option and it will show you all the node devices with their hop count. If you wish to get the information of internet speed, use the speed test application as shown in the video. This brings us to the end of this video. Thanks for watching. For more information, please visit our website www.dratec.com.au, or you can even email us at sales@dratec.com.au.
Okay, a little bit laggy, but not too bad, I guess. Higher-end Draetech routers, which include the Wi-Fi mesh feature, also support access points connected to the router with cables. This is known as mesh wired uplink. When using a Wi-Fi router as a mesh route, Vigor AP mesh nodes can be connected to it via cables or Wi-Fi. One situation where you might want to use mesh wired uplink is when your Vigor APs are powered by PoE from a switch and you want a mesh network. Because they're attached by cables which provide both power and data to the APs, a loop between the wireless and wired connections for each AP occurs. Enabling the wired uplink option will prevent this loop. To set up a mesh wired uplink, firstly log into the APs and go to the mesh setup section. The wired uplink checkbox will appear when mesh node is selected. Then on the router, it's simply a matter of enabling the router as the mesh route using either the mesh setup menu or the mesh wizard, and then adding the mesh nodes. Another option, if you need an AP to be the wireless route and the router's Wi-Fi broadcast to remain out of the mesh group, you can set it up per this diagram. I'll now pass you on to Harvey, who will briefly go through the hands-on demonstration on page 66 of the training manual. In this one, we'll be setting up a mesh Wi-Fi mesh network with the Vigor 2865 LAC configured as the mesh route and 2 other access points set up as mesh nodes. Okay, over to you, Harvey.
Thank you, Darren. The spotlight on the equipment that we have now. We have an AP 903 and an AP 802 and our 2865 LAC. Let me go straight to my computer. No, oops, here we are. And to make things go faster, I have recorded this this Wi-Fi mesh. I'll go to the 2865 and check the SSID for the 2.4 and the password also. And we do the same for the 5 gigahertz Wi-Fi. Check the SSID name and the password. So once this is done, we'll go to the mesh setup. We enable it, and then we click OK. Take a few minutes for it to be enabled. We don't need to reboot the route at this stage. Then we do a search, we apply. And it will take a few minutes, between 5 to 10 minutes, depending on your environment. And now we have our two AP ready. We select them, give them a device name, some user-friendly one like AP903 corridor, dining room, whatever. And we apply. It will take another 5 minutes to do the search again before it appears on main mesh group on the top. Now you can find number 2 and number 3 is already there. We go to the mesh status and click on refresh until the red becomes yellow and then green, which means that all of them are now online and ready to go. Let's go and log into one of the AP, admin, and we'll check the operation mode. Operation mode is mesh mode, and we check the SSID and the password and any other Wi-Fi settings that are being done on the root node will be transferred automatically to all the APs in the mesh. It's as simple as that, and the job is done now. Okay, so this 3-minute presentation replaced the 15 minutes setup. And a few things also I would like to mention that you can use an AP as a root mesh. And if you can do that, it will offload the CPU of the router of some work done. And also, Dratech access points are by default in mesh mode. So if you do a factory reset, it will go into mesh mode ready for joining any mesh available. So if you want to use a wired uplink, you have to log in on the AP and then change it to the wired uplink as shown before. Also, another thing you have to be careful and aware, the mesh feature only replicates all the settings from the root mesh. All the Wi-Fi settings such as Airtime Fairness, roaming, band steering, password changes, and all that must be done on the root before deploying to the mesh nodes. Okay, now I'll hand it over to you, Darren.
Okay, back to me. Thanks for that, Harvey. Okay, so now that we have an understanding of Wi-Fi mesh networks, I'll go over some deployment examples based on scenarios that we've encountered. The first one is one Java I mentioned earlier, which is a commercial application called DigiValet, used by luxury hotels in Dubai, India, China, and other parts of the world. It utilises Draetech Vigor APs along with tablet PCs in each room, and it allows guests to control lighting, air conditioning, TV, the sound system, order in-room service, browse the internet, watch movies on demand, and much more. Next, we had a holiday park needing a Wi-Fi solution. They had the main internet connection in the administration building and wanted to give guests internet access throughout the park. Due to the large area to be covered, a number of outdoor access points was required, and because there was no data cabling in place, wireless bridging between those access points was also needed. So a Wi-Fi mesh solution was the answer. There were a number of challenges to be considered when selecting a suitable access point. Firstly, they had to be durable and have weatherproof IP67 rated enclosures. They had to be sturdy and pole mounted, which also meant they had to be industrial grade and not affected by extreme temperatures. We also needed 802.11ac Wave 2 Wi-Fi, high gain wireless capability, and they needed to be PoE powered. And as I mentioned, due to the lack of cabling, we needed support for Wi-Fi bridging between access points. We also had IP cameras that needed power and internet, and we also needed hotspot capability with a website landing page. And here's the solution. This diagram shows the layout of the holiday park. The internet link comes into the main office through a Vigor 2865 router, which also has a built-in wireless hotspot feature. The router is connected to a Vigor AP 918R access point, which acts as the Wi-Fi mesh route. And we have a bunch of Vigor AP 918RPD access points located throughout the park, set up as mesh nodes. The RPD model has a PoE out port to provide power and data for the IP cameras. We're still working on this webpage on our site, but I'll just include a link in the chat box there to the specs of that one on DrayTek Taiwan's site. We needed wireless bridging capability on this site due to the distances involved and the challenge of running UTP cabling. The Vigor AP 918 RPD series is well suited for point-to-point bridging due to its internal high-gain directional antenna. Placing the access points closer to each other will ensure higher Wi-Fi speeds as well as better coverage. The Vigor AP 918R series supports Wi-Fi mesh technology, where each access point can be auto-configured from the mesh route. This technology is ideal for covering large areas where it's not possible to install structured cabling. And in addition, the Wi-Fi mesh will self-heal if an access point fails by automatically reconfiguring the remaining access points to reroute connections. The next deployment example we'll look at is providing Wi-Fi coverage in a heritage listed building. Here, no additional cabling is permitted to be installed throughout the building to provide internet access, so the only option is to use Wi-Fi bridging. There were a number of challenges here, as you can imagine. The main one was that the walls were of sandstone construction, which severely impacted the wireless signal, so placement of wireless access points was critical to get the best possible coverage. The rear of the property had an extension housing the entertainment area, which also required Wi-Fi. The NBN service terminates into a Vigor 2927AC router placed at the front of the house, circled in red here. As shown in the floor plan, the Wi-Fi coverage from the router only extended partially to adjacent rooms. Those sandstone walls really took the Wi-Fi signal out. The entertainment area down the back had pretty much no signal, so additional access points had to be placed at locations to extend the coverage. A Vigor AP 903 was deployed in the dining room and it covered most of the house, but the entertainment area down the back was still struggling. The signal strength measured there was 70 dBm, which was too weak to improve on. In addition, there was a blind spot in one of the bedrooms, so it required another AP 903 set up as a mesh node. The router was set up as the mesh route. The mesh status showed that the connection in between the router, the 2927AC, and the Vigor AP 903 on the mesh configuration had a 68% RSSI. The recommended RSSI is 50% or minus 70 dPm between APs. So a second Vigor AP 903 is deployed at the rear of the property to complete the coverage of the building, importantly providing Wi-Fi to the entertainment system. It's also set up as a mesh node coming off the first access point, so second hop. Here we have the mesh route status showing the second access point is connected. The RSSI signal on the AP is 83%, which is good, so job done. The last topic we'll cover today is tips for improving Wi-Fi networks. Hopefully this will help you troubleshoot some wireless issues you might encounter. The first one we'll look at is a slow wireless connection. This is mostly due to interference from neighbouring wireless devices using a wireless channel close to the channel that you're also using. As shown in this diagram, adjacent wireless signals overlap, so it's best to have a 5-channel separation between adjacent access points. Draetech access points have a diagnostic feature called Interference Monitor. Here it will scan the wireless network and report on adjacent access points and the channel utilisation, then suggest a channel to use which has less congestion. Other points to consider to improve slow Wi-Fi connections are enabling the band steering feature to encourage dual band capable devices to connect to the 5 GHz band. The 5 GHz band provides faster data rates over short distances, so they're better off there anyway, and it also frees up the 2.4 GHz band, so it'll be less congested and improve speed for those wireless clients. Also, watch out for sources of interference such as ceilings and walls and metallic furnishings like shelving and cabinets. These can heavily impact Wi-Fi signals, so try to locate your APs away from those. A tricky one to troubleshoot is when wireless connections are frequently disconnecting. This can often happen when Wi-Fi roaming has not been adequately set up. To check if this is the case, look for the DrayRS message in the syslog and the matching MAC addresses. To verify that Wi-Fi roaming is the cause, you can disable this function. Then refer to the application note number 5764 linked at the bottom there to further troubleshoot and adjust settings. When band steering is enabled, the access point will stop handshaking for a few seconds while the wireless client is trying to connect to the 2.4 GHz band. The default time delay is 15 seconds, but can be modified in the band steering setup page. When we find wireless clients still connect to 2.4 GHz instead of 5 GHz, we can check the information in the syslog as shown here. For example, when the wireless client tries to connect to 2.4, the access point will block the connection until the time period has expired. When we find that the wireless clients are not connecting to the 5 GHz band, we can check that both 2.4 and 5 GHz bands are visible from the wireless client when disabling band steering by putting them in separate SSIDs. Also check that the 5 GHz is supported on the wireless client and check the compatibility between the AP and wireless client. When setting up Wi-Fi mesh networks and you encounter difficulties, the first step is to enable the detailed log and check the sys logs, then find connection logs with the DMN prefix. If the issue is due to a low RSSI, you'll see syslog entries similar to those shown here. The two numbers in brackets are the signal strength of the mesh node and the RSSI threshold. The signal strength of the mesh node must be greater than the RSSI threshold. To adjust the RSSI threshold, you can use the telnet command dmn set as shown here. If all else fails, you can use the range extender mode as a workaround. Okay, quick quiz. Which of the following will not help avoid interference? So not help avoid interference. A, change the operating signal, use 5 GHz instead of 2.4, set the channel width from 20 MHz to 40 MHz, keep it away from the microwave. Okay, please raise your hand or type your answer in the chat box. We've got a D, keep it away from the microwave. Got a lot of Ds. Okay, this is not help avoid interference. Okay, we've got a couple of Cs. That's about it. Let's move on. And the answer is C. So setting the channel width from 20 MHz to 40 MHz. Doing that will actually make things worse if your issues are due to cross interference coming from neighbouring APs. Microwaves use 2.5 gigahertz. Is that? Oh yeah, they do. It's really close to 2.4, so it can interfere, but we were looking for solutions that wouldn't provide an answer. Yeah. Okay, this takes us to the end of this workshop session. You can refer to the course notes for more details on any of the topics covered here today. To summarise, today we started with an introduction to Wi-Fi technology and the standards. Then we looked at some wireless technology components, covered some basic antenna theory, then went through the configuration menu options in both wireless routers and access points. We also looked at how to set up Wi-Fi mesh networks, including a live demo, well, sort of live, of an exercise you can try later. We also looked at some deployment examples as well as some Wi-Fi troubleshooting tips. And now we have 15 minutes or so if you'd like to ask any questions. If you can't hang around, please fill out our survey to let us know how we went. Let us know what you liked or what you think needs work. I'll add a link to that in our chat box right now. I'll just find it. There we go. And there it is there. Okay, filling that out will also qualify you for a 30% discount for one of any model of Draetech access point valid until the 30th of June. Right, thanks everyone for coming along today. We hope it was helpful in developing your knowledge of Wi-Fi and how to use the Wi-Fi features available in Draetech products. Don't forget to fill out that survey before you go. And if you're not subscribed to our newsletter to receive a heads up about our next workshop, please drop us an email to sales@draytech.com.au. Okay, over to you, Edward. Yep, keep the comments coming in the chat box there and we'll keep responding there. If it's easier to talk rather than type, just stick your hand up and we'll put the spotlight on you so that you can come over using your webcam and microphone instead if that's easier.
Yeah, we've got a question from Martin about if you've got two pieces of equipment, what's the difference between mesh and bridge modes? Essentially, there'll be no difference because you've only got two devices talking to each other. So mesh is only useful if you've got more than two or more access points to connect to the root device. Yeah. So.
Okay. I'm gonna answer to additional answer to Martin. So the difference between the mesh and the bridge mode, mesh, it has a feature that self-heal. So if two connection just lost a uplink, it will try to connect both devices. So that's the only difference with the bridge mode. If you have a bridge mode, once the connection is gone, it will not try to reconnect. Okay.
Okay, we got another question. Can Dratec AP join mesh node with different Dratec or non-Dratec mesh route? I think it only works with Dratec devices only. I'm not aware of it working with other brands of devices. So, so I suppose the answer for that would be no. And another question from Nick, how to configure VPN access using Wi-Fi connection. I suppose there you can probably use smart VPN client. It would just be a PC connection to your network. Then about LAN-to-LAN connections, maybe using a Wi-Fi WAN connection. You can use that. If anyone wants to speak, you can just raise your hand and we'll let you have a chat as well. If you don't want to type in. Okay, there's another question here. What's the suggested setup for an environment that has mainly BYOD and internal devices? Yeah, Edward, do you have any suggestions for that one?
Okay, this one, bring your own device. To connect. Okay, this one is a little bit, there's a lot of ways you can isolate a client. Either you can do a different SSID, or on the AP, there's an isolation feature as well. So I think it's better to just answer through email, maybe.
Yeah, I think mainly, I suppose you can use VLANs as well to separate the devices or guest users from the main users. So I suppose you can do that setup like a guest Wi-Fi network on a separate VLAN, and that way you separate them from the main connections, the main devices. There's another question: does Dratec allow exclusions to allow multicast by MAC? Is problems? Okay, that's someone else replied to that one. Okay, so any other questions? Okay. And if anyone else wants to add to that response.
Okay, somebody raised his hand. It's Martin, I think.
Okay, so we could turn on the microphone for him.
Okay, Martin, can you, if you want to talk, you just turn on the mic.
I have an application. I have two warehouses in like a Kennard's thing, and I've got the access point in one warehouse and devices that need to be contacted in the second one. Now the problem is that when all the roller doors are down, the signal can't get through from the NBN warehouse to the other one. So I've stuck a couple of antennas outside the roller door, but I'm not sure if this is good for the equipment that's in the NBN warehouse. So it's got to communicate to the other warehouse and to its own when the roller doors are closed, because they act sort of like a Faraday cage. So I'm just wondering what would be, what's the best way to get around that? Because once the roller, so what's the best devices so that I can communicate internally in each warehouse, but communicate across as well. They're only about 20 meters apart, but they both got a roller door, I think.
So you might need an external antenna.
Yeah.
If you use the 918R, that's an outdoor access point.
Yeah.
But that's you can probably place it outside the building, but you're still going to block the signal going inside the building. So probably probably an external antenna is what you need.
Well, the thing though is, if I put the antenna outside the warehouse, then when I close the roller door, it can't communicate with any of the devices inside the warehouse. So how do I get them to communicate inside and outside the roller door?
Okay.
Okay, good.
Okay.
I think.
Yeah. We need to probably look at that because I think you can use. I think most of them perhaps have one antenna enabled. You probably need to look at that to what proper solution is. Maybe Harvey might have some experience with some installations. He's got some ideas on this setup.
Very difficult. I think if you can use more access point, getting get it more nearer to the metal door. I don't know, because your access point seems to be a bit far, and when it goes to the metal door, it's already lose like 20% or more of the signal. But would be good to send us an email, and then we can follow it up and maybe take it up and escalate it if necessary.
No worries.
Yeah, one option could be to mount the access points up in the up high above the roller door.
Well, you can't, because there is no above the roller door. There's the roof.
Okay, it goes all the way up. Okay.
They basically don't want people coming in over your roller.
Okay.
But I could have the router connected to the NBN and then cable it to use a network lead to an external antenna, then have an external antenna on the other warehouse, and then
Yes, have directional antennas. Yeah.
But that's using 4 routers and devices.
I know. It's a bit of an overkill.
Yeah. And it's not that far away. It's only got like 3 or 4 devices in each building, so it's not like 4 devices.
Okay, maybe running a LAN cable might be one option, but that's could be risky.
Yeah, but it's I have to run it through the whole network and then through the whole building, whereas the wireless was just. So what I'm doing is like the routers that I've got like 2 or 3 antennas, and so I have a couple of the antennas extended outside and 1 or 2 inside, and I'm hoping that the router just doesn't seem like a professional sort of solution. It sort of works.
Yeah.
Yeah.
I suppose the option is just to put an outdoor antenna, but you need to have depends on the length of the cable. You will get some loss in signal.
Yeah.
So you try to need.
Well, just in case, how do I get the signal inside the warehouse?
Yeah.
The antenna outside the roller door.
Yeah.
So I do a landline network lead. It's silly to have the 2 antennas on the other side of a warehouse just because there's a 2 mil thick metal plate door.
Yeah. I wonder if anyone else had that sort of experience from if they've got some other suggestions.
Yeah, some just.
I think it's better to send the layout of the building or some sort of pictures and through our support, and then we'll just check it out. What's the possible solution?
Yeah.
Okay, I'll do that.
Okay.
Thank you, Martin.
Okay. Is any someone else got their hand up?
I think that's Martin.
Oh, just Martin still. Okay.
Okay, I just.
Okay. One other topic I was looking at covering today was management of access points, and we're going to leave that to another session. But there's 3 ways of managing access points. One is using in the router, you've got the central AP management, and then you also got Vigor Connect and ACS2 and Fisher ACS3. So that's the 3 ways. And we have to cover that in another workshop. But probably for a local network, probably Vigor Connect's probably a good way to go to monitor and configure your devices. And what I'll do, I'll put the PowerPoint slides for today's session on the same download site on our FTP server. So if you wish to have a copy of that, we can, probably later on this afternoon, I'll put that on there. And also the workshop manuals there too, if you want to have a look at that. But if you've got any questions, you can always send us an email if you want to know more information or something else to improve the workshop for next time we run it. So just see if there's any more questions. Okay.
Series wide antenna.
Okay, there's another question here. Just try and get it up on the screen. Are you able to explain the abilities of guest networks? Is there a portal for login? And is it okay to have a non-secured network for guests? So I don't know if anyone wants to answer that one. Guest networks are mainly just for visitors to your business, and we just provide limited access to the internet. And there's a portal for login, and that's with the Hotspot Portal, and we're developing a webinar on that, which we're going to show in the next few weeks, I think. So you can use the Wi-Fi Hotspot Portal for guest login, and you can also have things such as authentication of users and quotas for network usage.
And you can also assign it to a different VLAN to isolate your main network from the guest network also.
Yeah, that's right. Yeah. And you can also apply firewalls to the VLAN as well. So if you want to restrict access to certain websites or just direct them to your company web page, you can do that as well through through the firewall settings. Okay, just see if there's any other questions. Yeah, we are planning on running more training sessions in the future, but if you've got any suggestions for the next topic, you can let us know as well. And we're still in the planning stages for the next workshop, so if you've got any preferred topics you want us to cover, we can look at those as well. Okay. Okay. So anyone else wish to add to any comments or anything?
On another note, we have Dratec has released recent firmwares for a lot of routers. They have an issues with the MyViga server. I hope that has been solved now. I'm getting less and less ticket, and mostly for those who are using WCF and DDNS, they would be affected, or else they won't be much affected. But of course, updating to the latest firmware is always recommended. So if you have any issues with WCF and DDNS, just let us know, and also send us your MAC address also. That can help. Okay.
Okay. Now I've got a question here from Martin, and he's saying, how secure is the gap between the two networks? He has ATMs use wireless and wants to have a SSID for guests. So if you're putting the guest SSID onto a separate VLAN, then they'll be totally isolated, and you can you don't turn on routing between the two networks. And if you want to allow some access, you can enable firewall functions, but you can totally isolate the guest network from your main network. And you can set up so that the guest Wi-Fi can only go to the internet and only to selected sites, but not access your, say, your ATM machines. And there's a question about the MyViga emails that got lost. I suppose for that you maybe Harvey might have.
Yeah. I just say if they
one.
send us an email, we can try to escalate, because I'm not sure how we can lose it. But anyway, this can be treated on email, and we can escalate to DrayTek Taiwan.
Yeah, so probably just send us an email, and we'll contact Dratec, and they can reactivate your email account, or try to recover it for you. Okay, so there's any other questions? So when will 2865 be supported in the Draetech Mesh app? I think the latest firmware for 2865 AC router does support mesh route function. So it's only a route, not a node device. So it's already available. Yeah. And also in the 2862, the latest firmware also supports the mesh function as well. And I think the latest firmware with 2065 was released about 2 weeks ago. So it's worth trying that one. Okay, there's another question. Does Draetech have issues with group rekeying being sent out sync for multiple SSIDs? I'm not too sure about this one. Can you send us an email to support for that one so we can chase it up? I'm not too sure about this issue myself, so it's something we're probably to check with Draetech as well, see what they got to say about it. And there's another question: do any of the management options, there are 3, support automated configuration backup? I think Viga ACS2 does this. I think Harvey's more familiar with ACS2. If you can comment on that.
Yeah, ACS2 will allow you to do automated configuration backup and firmware upgrade and all that. But I'm not sure Viga Connect can do that much.
Okay, for the Viga Connect as well, I can confirm that it can do a backup as well.
That's good.
And also the central management, AP, switch, and they can do a backup as well, automatic backup.
Okay. Any more questions? Or let me just check. Yeah, as I mentioned, we are planning on covering the different management options in another workshop. We're going to include it today. I was going to take the workshop to probably maybe 2.5 hours, so we didn't include it today. But we will probably look at that later. Okay, so we've got this. So the mesh has been created successfully as a route, and routers on the latest firmware.
Yeah.
Okay, but no device.
Better tweet it on a ticket. Just send an email.
It's probably just as soon as a support ticket for that one. It should be working, but we'll probably need to have a look at the configuration of the access point and router, and also the firmware versions that have been used. Yep. If you're on an older version of firmware, it's best to update it first, and then send us a copy of the configuration files, and we'll try to simulate it and see what's causing the problem. Okay, and we've got another question. What will happen if Draetech IP and non-Draetech IP have same SSID and PSK password? If they're on the same network, I suppose devices will connect to both.
First come, first serve basis.
Yeah, that's right. For the clients, it doesn't really matter if it's a Draetech or non-Draetech. It just sees the SSID and the password. So you can have a mixture of both in your network.
It depends on the strength of the signal. The better strength will get priority, I think. Yeah.
Yeah, that's right. Yeah. So you can have a mixture of different devices. The only drawback is that with non-Draetech, you can't add them to the mesh network. Manage them using the Draetech management tools.
I have actually done this in my home, and what I find is they don't automatically roam. The client has to actually drop out from one access point, but then it'll automatically reconnect to the other one.
Okay, so that's something worth noting. Okay. And the wireless app works with APs, not routers. I think that is correct. I think Edward's had experience with the wireless app. Edward, do you want to comment on the wireless app?
Yes, regarding the wireless app only works with APs. So you use your mobile phone installed with the wireless app, and then you try to set up an AP. It's an easy way and fastest way to set up an AP, either an AP mode, a mesh, either root or node, and extender mode. So yeah, if you have an AP, try to set up, use wireless AP. It's a easiest way to go with.
Okay, and I'm not too sure that Java's mentioned some new products coming out. I think we're expecting some AX access points coming.
We do have the 960C that was launched a couple of weeks ago. As far as the AX routers are concerned, I'd expect some clarity perhaps by the end of July. Not this quarter, that's for sure. Facing supply shortages as is.
I think his microphone's off.
There you go. Okay. All right. As I mentioned, the 960C, the access point was released a few weeks ago. It's been doing well. As far as the routers concerned, we hopefully get some stock. There are supply shortages as is.
I think the mic is not working. Take this.
Okay, we've got problems with microphone.
No.
You just change it.
I think it's better.
Okay.
Thankfully, it happened.
Yeah, that's fine. That's what teamwork's all about. All right. For the third time, we are facing supply shortages. There are issues with a few LTE models, as a lot of you may know of. So when it comes to AX routers, we'd expect some stock come next quarter, hopefully, if things get stabilized. But in the meantime, if you want to get your hands on one of the latest Wi-Fi 6 enabled access points, we have plenty of 960Cs. Those are for sale in the market. So just click us a quick mail to sales@draytech.com.au or 0298 38899 is the number. Just give us a call. We're here to help. Right. 960C. We have a video up on our YouTube channel as well that Aaron did recently. We have stock of the latest Wi-Fi 6 APs. Routers hopefully will be coming in sometime in the next quarter.
Okay. So I think there's no more questions.
Martin's got his hands up again. All right, Martin, on to you. Just unmute before you speak.
Yeah, one thing, I'm trying to find that Wi-Fi analyzer app that you guys have, but there's like dozens of them. Which one is yours?
We paste the link once again. Must be up in the chat someplace, Martin.
Yeah,
I'll look it up.
How to get that
Do
onto my phone, that link?
Okay, Edward, could you do that? The analyzer app. Just paste the link that for download.
Yeah, but how do I get that link onto my phone? I'm on the Play Store. So which one is yours? Do you have a picture of which icon you have, or what company name does it say it's from as well?
Do you have that installed on your phone now, Edward? Show me the icon if you could.
I'll show you the icon.
Is it FarProc?
All right.
Oh, it's a bit blurry. Yeah.
Yeah, it's a bit blurry. Just hold it there for a second, just so I can focus.
Yeah, it's gonna focus back. Don't worry about it.
All right. Just hold it there for 1 second if you could. Don't move it. Just 1 second.
Edward, you need to turn off your the effect, the background effect.
Yeah, the blur thing. Just to put that on.
That one. Okay. Yep.
It's called Wi-Fi Analyzer. Yeah.
Wi-Fi analyzer.
Yeah.
FarProc.
Before. It's got olga.com.
Oh, that's Android.
This is Android.
Yeah, I'm on Android.
So I think there's another version, different version on.
It says it's from olgor.com. OLGOR. From FarProc or Olgor? I'm just wondering if anyone's copied your icon and used their name on it.
I think Martin is better to send an email to us so we can just continue discussing.
Martin, I think you can use the one from olgo.com.
You guys?
Better rated. You're probably better off sticking to the one with better rating. It's got 5 million plus downloads.
Yeah, Atlantis also has suggested another different one which works the same. So
okay,
use the one from olgo.com.
Yeah, downloading it now. Thanks.
Just a quick reminder to everyone who's still with us to fill up the survey link that Dan's just posted there. That's going to qualify you for a 30% discount for any of our Draetech access point models. This one's going to be valid till the end of June this year, so please make good use of this.
Ming.
I see Ming's got his hands up, so I'm gonna put you on spotlight there, Ming.
Hi everyone. I just want to say something before we close off for the day. It's a really international effort, and I appreciate our guests from New Zealand and Taiwan. And of course, there are 2 hours delays from Western Australia and Taiwan, so it's a bit early for them. But this is the issue that we can look at the next time. I appreciate the participation of our guests, and your participation are an important part of this event, and not just for today, but at any time, your ideas and suggestions will be more than welcome. We strive to help our customers in your requirements, and I'm glad that we have a very good relationship with everyone. We work like a family, or extended families, and yeah, that's very good. And I hope we'll continue to enjoy these relationships. When the pandemic is over, we will go back to face-to-face workshop. But this online workshop format, it seems to work quite well, and I'm sure that we will continue on in this part as well. So thank you, everybody, and stay safe and healthy, and enjoy. Okay, thank you, everyone.
So,
Okay.
Thanks, Bing.
Yeah, I'll mute
Thanks,
my mic now.
Thanks everyone for joining in today's session. We really appreciate your time, and really hope that the session was informative and fun. Please do share your feedback with us. We read it, and we're going to make sure that we keep improving our presentation and the contents, and try to keep it as relevant as we can in our future sessions. So here's hoping to meet all of you once again in our future workshop. Have a lovely day, and stay masked, stay safe. All the best.
Okay. Thank you, Ron.
Thanks, everyone. We'll see you next time.
Thank you. Bye.